In section 3.3, we talk about truth tables for negation, conjunction, and disjunction. So if you aren't comfortable with the definitions of negation, conjunction, and disjunction, I want you to go back and look at the video for 3.2 and 3.1. If you don't have a good grasp on these definitions, the truth tables will be a lot harder. So according to University of Texas economist Daniel Hammermish, strikingly attractive and good-looking men and women can expect to earn an average of $230,000 more in a lifetime than a person who is homely or plain. In this section, you will work with a bar graph that shows the distribution of looks for American men and women, ranging from homely to strikingly attractive. By determining when statements involving negation, which is not, conjunction, which is and disjunction, which is or, are true and when they are false, you will be able to draw conclusions from the data. Classifying a statement as true or false is called assigning a truth value to the statement. So we're going to start with negation. The negation of a true statement is a false statement. We can express this in a table in which T represents true and F represents false. The negation of a false statement is a true statement. This too can be shown in table form. Combining the two tables results in what is called the truth table for negation. The truth table expresses the idea that not P have the opposite truth value from P. And so in table 3.10, you can see what negation would look like. For conjunction, let's just say a friend tells you I visited London and I visited Paris. In order to understand the truth values for this statement, let's break it down into two simple statements. We'll let P be I visited London and Q be I visited Paris. We have four possible cases to consider. Your friend actually visited both cities, so P is true and Q is true. The conjunction I visited London and I visited Paris is true because your friend did both things. If both P and Q is true, then the conjunction P and Q is also true. Case 2. Your friend actually visited London but not tell the truth about visiting Paris. In this case, P is true and Q is false. Your friend didn't do what was stated, namely visit both cities, so P and Q is false. If P is true and Q is false, then the conjunction is false. In case 3, this time London was not visited but Paris was. This makes P false and Q true. As in case 2, your friend didn't do what was stated, so P and Q is false. So if P is false and Q is true, then the conjunction is still false. And the last case is this time your friend visited neither city, so P and Q are both false. The statement that both were visited, P and Q, is also false. So if P is false and Q is false, then we get P and Q is also false. So only in the case that your friend visited London and visited Paris in the conjunction is true. Each of the four cases appears in the table below, and this is the truth table for, I should say, conjunction. So a conjunction is true only when both simple statements are true. That's the biggest thing I want you to pull from this. An and statement is only true when both of them are true. The statements that come before and after the main connective in a compound statement do not have to be simple statements. So consider, for example, the following compound statement. Not P or Q and not Q. The statements that make up this conjunction are not P or Q and not Q. The conjunction is only true when both not P or Q and not Q are true. Notice that not P or Q is not a simple statement. We call this a compound statement of the conjunction. The statement making up a compound statement are called component statements. Now let's talk about disjunction. So now your friend states, I will visit London or I will visit Paris. Because we assume that the inclusive or, if your friend visits either or both of these cities, then the truth has been told. The disjunction is false only in the event that neither city is visited. An or statement is true in every case except when both component statements are false. So a disjunction is false only when both component statements are false. And you can see the truth table behind that one. So they're all true unless they're both false. So let P and Q represent the following statements. P is 10 is greater than 4, and Q is 3 is less than 5. We want to determine the truth value for each statement. So P and Q. That says that 10 is greater than 4, and 3 is less than 5. Is 10 greater than 4? That is a true statement. And we use our little arrow up. And 3 is less than 5 is also a true statement. So because the only time our conjunction is true is when both are true, that means that this is a true statement because both of them are true. What about not P and Q? So that says that 10 is not greater than 4 and 3 is less than 5. Well, the first part of our statement is a false statement and the second part is still true, but because both of them are not true, this is a false statement. In part C, we have P or not Q. So 10 is greater than 4, or 3 is not less than 5. Well, the first statement is true, and the second statement is false, but this is now a disjunction, which is an or statement, so only one of them has to be true for this to be a true statement. And since we have one true statement, the whole thing is true. And the last one, not P or not Q. So 10 is not less than 4, or 3 is not less than 5. So this is a false statement or a false statement, and the only time a disjunction is false is when they both are false. And so this is also false because none of them are also true. Now, truth tables can be used to gain a better understanding of English statements. The truth tables in this section are based off negation, conjunction, and disjunction. So here is a quick little box of definitions. Negation is not, which gives you the opposite truth value than the original. Conjunction is true only when both statements are true, and disjunction is false only when both statements are false. Breaking compound statements into component statements and applying these definitions will help you construct truth tables. So let's just look at the process for constructing truth tables for component statements containing only P and Q. So we start off by listing the 4 possible combinations of truth values for P and Q. So we have true and true, true and false, false and true, and false and false. We'll determine each column heading by reconstructing the given compound statement one component statement at a time. The final column heading should be the given compound statement. We'll use each column heading to fill in the 4 truth values. So if it involves negation, we go back to the original column and put the opposite truth value. If it's a conjunction, we fill in the truth values by looking back at the 2 columns and seeing if both of them are true, then it's true. If they're not both true, then it's a false statement. And if it's a disjunction, we're looking back at the 2 columns and we want to see if we have at least one true statement, which would make it true. The only time it's false is when both of them are false. So let's construct a truth table for not P and Q to determine when the statement is true and when the statement is false. So let's go ahead and set up our table for this statement. So you need to have 4 rows to put the truth values in, and we want to make sure we leave the top as a header. So we're going to deal with P in the first one. We're dealing with Q in the second one. And so let's just start with that and fill in the truth values for those statements. So we've got true and true. We've got true and false. We've got false and then true. And we've got false and false. Those are our 4 options. What we want to do next is we want to look at that and statement first and then negate it. So we're going to look at P and Q first. And so the only time that an and statement is true is when both of our statements are true. So we can see from the row that P is true and Q is true, which means that one has to be true. In the second row, we have a true and a false statement, which makes this a false statement. In the third row, we have a false and a true statement, which makes this again false. And 2 falses will make a false statement. And so now that we have the truth values for the and statement, we want to negate what we just found in the previous column. And so all we do for negation is we want to take the truth value and make it the opposite. So the first column will become a false statement. The second row becomes true. The third row becomes true. And so does the fourth row. So the only time this statement is false is when P and Q are both true statements. And all the other categories, it's a true statement. And so that's kind of the idea of how these go. You take them piece by piece and look at the truth value so you can find the truth value for the entire statement. So let's go ahead and try this with example number 3. We're going to construct a truth table for not P or not Q. So setting up our table, we're going to have a few more columns going on here. The first one will always start with the most basic, which is P and Q, and then we can fill in the values. We got true and true, we got true and false, false and true, and false and false. We want to look at both of these negations separately before we take the or statement of them both. So we're going to do not P, and we're also going to look at not Q. So not P, we're taking the truth values from the first column and we're negating them, or changing them. So because the first column is true, true, false, false, my not P column will be false, false, true, true. Same idea goes for the not Q column. So we're going to take the second column and negate the truth values. So because it's true, false, this is going to become false, true, false, true. And in the last column, now we want to take the or of those 2 previous columns. So we're looking at not P or not Q. Well, or statements are true as long as both of the statements are true. Either one of the statements is true, pardon me. The only time it's false is when both of them is false. So looking at the first two, because now what we're looking at is just this not P or not Q. We don't care about the original columns. And so I have two false statements, which give me a false. I have a false or a true, which is true. I have a true or a false, which is also true. And I've got two trues, which is true. So this is a true statement when the originals are either true or false, or both false, and it's a false statement when the originals are true. Example 4 is going to be a little bit more tricky. You just have to be organized. So we need to set up our table first. So setting up our table. Got a few more columns going on here. Those first two columns are always just going to be the P and the Q. And then we want to set up the original truth values. We got true and true, true and false, false and true, and false and false. So let's go ahead and break this apart. Let's look at the left-hand side first. We need to know not P. And so we're going to look at the first column and negate all of the truth values. So we've got false, false, true, true. And this is now going to get conjuncted with not P, disjunct with Q. So an or statement. So right now we're looking at the second and the third column, and we want to see if we get a true or a false. So true or a false statement will give me a true statement. A false or a false statement gives me a false statement. A true or a true gives me true, and a false or a true gives me a true statement. So we have the truth values for the left-hand side. Now we need to find the truth values for the right-hand side. And so this is the not Q. So we go ahead and we negate the second column's truth values. We'll get false, true, false, true. And now we're going to find the conjunction of the last two columns that we wrote down. And so the only time this is true with an and statement is when they're both true statements. And so we have true and false, which is false. We have false and true, which is also false. We've got true and false, which is false, and we got true and true, which is a true statement. Now some compound statements, such as P or not P, consist of only one simple statement. In cases like this, there are only two true-false possibilities. P can be true or P can be false. So let's go ahead and construct a truth table for that statement, P or not P. So it's going to be a lot simpler this time. We only have one letter we're looking at. We're looking at P. And P is either true or it's false. We don't have any other option. We also want to look at not P. And so all we do is we just switch true to false and false to true. The original statement is P or not P. And so that is always true as long as there is a true present, and it's false when both are false. So we have true or false, which is true, and we have false or true, which is also true. And so this is a true statement no matter what the value of P is. And so a compound statement that is always true is called a tautology. Some compound statements involve three simple statements, usually represented by P, Q, and R. In this situation, there are 8 different true-false combinations. The first 2 columns have 4 T's and then 4 F's. The second column has 2 T's, 2 F's, and 2 T's, 2 F's. And the third column alternates T with F. It's not necessary to list them in this order, but this helps ensure that no case is repeated and that you hit all of the cases. So we're going to construct a truth table for the following statement. I study hard and ace the final, or I fail the course. So the first thing we want to do is we want to list out what these simple statements are. What is P, Q, and R? So I'm going to write P is I study hard. We're going to let Q be I ace the final. And we're going to let R be I fail the course. And so we want to set up our truth table now that we've written down our simple statements. So we're going to have 8 rows with the header. We've got P, Q, and R. And so what the direction said is the first column, which is P, has 4 true statements and then 4 false statements. 1, 2, 3, 4. And then you follow with 4 false. Then it says in the second column, we do 2 trues, 2 falses, 2 trues, 2 falses all the way down. So 2 trues, 2 falses, 2 trues, 2 falses. And in the last column, we just alternate back and forth. True, false, all the way down till the end. Let's go ahead and write what this statement would be in symbolic form so we know what we're looking for. So I study hard and ace the final, comma, or I fail the course. So the commas indicate where the grouping occurs in the statement. So before the comma is I study hard and I ace the final. So that would be P and Q, or I fail the course, which is R. So that is the goal of what we're looking for at the end. So we need to figure out P and Q first before we combine it with this or R statement. And so we're only looking at the first 2 columns, and we know that and statements are true when both of the statements are true. So looking at the first 2 columns, we have true and true, which is a true. We have true and true again, which is also true. Then we've got true and false. So that's false, and true and false, which is again false. We have false and true, which is false. We have false and true again, which is also false. We have false and false, which is false. And we have false and false again, which also gives us false. Now we want to find the last statement, the P and Q or R statement. And so we're taking the column we just made and we're combining it with an or statement from the third column. So we're looking at the third and the fourth column. And we're doing an or statement. And so that means as long as there's one true present, it's a true statement. So we have true or true, which is true. We have false or true, which is also true. True or false, which is true. False or false, which is false. True or false, which is true, false or false, which is false, true or false, which is true, and false or false, which is false. So now it says, suppose that you study hard, you do not ace the final, and you fail the course. Under these conditions, is the compound statement in part A true or false? So let's think about each one of these. So for statement P, it says that I study hard, which is a true statement. That is what we let P stand for. For Q, we let it stand for I ace the final. So if I do not ace the final, that becomes a false statement. And R is you fail the course, which is a true statement. And so what you want to do is you want to go up to the table and find true, false, true, and see what that last column gives you. So we're looking for true, false, true, which looks to be this third row. And so what that tells you is that statement is a true statement. So let's determine some truth values for specific cases. A truth table shows the truth values of a compound statement for every possible case. In our next example, we will determine the truth value of a compound statement for a specific case in which the truth values of the simple statements are known. This does not require constructing an entire truth table. If we can get out of constructing truth tables, that is great. So example 7 is the bar graph that shows the distribution of looks for American men and women, ranging from homely to strikingly attractive. We want to use the information in the bar graph to determine the truth value of the following statement. It is not true that 1% of American men are homely and more than half are average, or it is not true that 5% of American women are strikingly attractive. So let's go ahead and list out our P, Q, and R before doing anything else. If we don't know the simple statements, we can't find the truth value. So P is going to be that 1% of American men are homely. Q will be that more than half of American men are average looking. And R will be that 5% of American women are strikingly attractive. So now that we've written out our simple statements, go to the bar graph and see if these statements are true or false. So 1% of American men are homely. So using the bar graph, the orange bars are the men. And so if I go under homely, it says that 1% of men are homely looking. So this would be a true statement. Let's go to more than half of American men are average looking. So let's go to average looking, and men are at 59%. So that is definitely a true statement because 50% would be half. And the third one, 5% of American women are strikingly attractive. So women is the yellow bar, and it's only 3%. So that is a false statement. So now that we've figured out the truth values for each of these statements, we can plug it into the actual statement we're looking for. So let's find out what the actual statement is. So it is not true that 1% of American men are homely and more than half are average, comma, or it is not true that 5% of American women are strikingly attractive. So before the comma, we have it's a negation. It's not true that 1% of American men are homely, which is our P statement, and more than half are average. So P and Q. Or it is not true that 5% of American women are strikingly attractive. So this is the statement we're trying to figure out if it's true or a false statement. So we know our truth values for P was a true statement and Q was also a true statement, but R was a false statement. And so a true and true statement gives you a true statement. And so a not true statement becomes false, and a not false statement becomes true. And so a false or a true statement gives you a true statement.